Hi everyone, welcome back to Lifey Technologies YouTube channel and thank you for watching. So this is a continuation of our IPRAN training series where I've been discussing how to implement different IPRAN principles on service provider networks. So in this episode, we'll be discussing how to implement IPRAN BGP Intra-AS on IPRAN network. And I've mentioned that when we are implementing BGP on service provider network, we have Intra-AS where we are doing BGP within an autonomous system and configuring IBGP or the internal BGP peering session between different nodes. We also have the Intra-AS where we are doing BGP peering sessions between different autonomous systems. So in this episode, we'll be focusing on just implementing within an autonomous system. So you have an autonomous system where you could be a cluster or a region, and you've selected, of course, you need to decide which AS number you'll be using. In this case, in our lab simulation, we'll be using AS number 100. And in this AS number 100, we'll be configuring BGP so that we are able to exchange service routes using BGP instead of using other protocol like static route or SPF. We will be using BGP to exchange the service routes. So we need to configure BGP peering sessions between different nodes. And as you can see in our topology, we have CSGs, we have RSGs, and we have ASGs. So from this topology, you can see that we have three rings. We have an aggregation ring, which has RSGs and ASGs, and then we have two access rings, access ring 1 and access ring 2. So access ring 1 connects to SG01 and SG02, while access ring 2 connects to SG04 and SG03. So when we are implementing BGP peering sessions, we need to configure BGP peering sessions from CSGs to the ASGs and then ASGs to the RSGs so that we have end-to-end connectivity. We will have routes being exchanged between these nodes and avoid any point of disconnect. So for the implementation of Intra-AS BGP, we need to follow some steps. So step 1, as usual, we need to do basic configurations. We need to ensure that we have IP address assigned on interfaces and also on the logical interfaces. So we will be assigning IP address on physical interfaces and on the logical interfaces. Remember, when we are doing BGP configuration, we'll be using loopback 0 as the connect interface because this is IBGP, and it's always good practice to use the loopback interface. Remember, the loopback interfaces will never go down. Provided you have reachability, our BGP peering sessions will be up. That's why it's always best practice to use the loopback interfaces when you are establishing IBGP sessions. So the next step will be configuring IGP in access and aggregation rings. So we'll be configuring ISIS as our IGP for this setup. And we'll be segmenting our network into different processes. We have access ring 1 using ISIS process 20, and then we have aggregation ring 1, which is in ISIS 100, and access ring 2 will be using ISIS process 30. Remember, the ISIS process is normally locally significant. So we'll be configuring ISIS as our IGP in this topology. The third step is to perform route imports between access and aggregation processes. So remember, once you've configured different access processes, the access and aggregation processes, you need to perform route import. So we'll be discussing again how do you perform or configure route import between the access and aggregation to ensure that there is reachability between different loopbacks from access to aggregation. Then our final step will be to configure BGP peering sessions between different nodes. The CSGs will be peering to the ASGs. The ASGs will be peering to the RSGs and CSGs. So that will be the final step. And of course, we need to perform verification to ensure that our protocols are running okay. So for step 1, so the topology is already set up on ENSP. And I've already applied all the configuration just to ensure that we don't waste time configuring one by one device. So once we've configured our, let me go back to the steps. So I've mentioned that the first step we need to do IP address and SIS configuration on all nodes. So I've bundled step 1 and step 2 in the same process, in the same step. So on RSG1, as you can see, RSG1, you need to configure the sysname, which is best practice. After you have configured the sysname, you need to configure the processor, the ISIS process that we are using. Remember, RSG1, we only have one aggregation process. So we are configuring ISIS process 100. We are specifying level to be level 2. And then we also configure as name. This name will be used, especially when you are troubleshooting and checking the peering sessions. You will see that the other devices will show RSG1 as a peer. So it tells you like I'm peering to this device RSG1. Then we are configuring the course style to wide. Remember, you can either configure it to narrow or wide, but wide is always recommended, especially when you are doing traffic engineering or you want to use higher values. The course style narrow only limits values from 0 to 63. So if you want to use bigger values, you need to configure the course style to wide. And then we configure the network entity. This is generated using the loopback 0 IP. So we configure the network entity, and this one is always unique. So you need to make it unique in the network. Once you've configured the SIS, we need to enable it on the interfaces. So on interface loopback 0, we assign IP address, and then we are enabling ISIS process 100 on the loopback 0. Once you've done that, we do the physical interface configurations. So we assign IP address, enable SIS, and then the final step, you do a commit. If the device doesn't pick the configuration automatically, you need to commit the configuration. So those are the configuration that we apply on RSG1. RSG2 is similar. You just need to change the network entity for SIS configurations. And once you've done that, you enable on interfaces, assign IP address, and enable the IGP on the physical and logical interfaces. So on SG2 is the same. We are doing the same configuration, but on SG2, remember we have two ISIS processes. We have ISIS 100 for aggregation, and we have ISIS 2 for ISIS 20 for access. So you need to configure the two ISIS processes on the SGs. And then you enable the ISIS process on respective interfaces. So on interface facing the aggregation or the RSGs, we enable ISIS 100, while on the interfaces facing the CSGs, we need to enable ISIS 20, which is our access ISIS. So similar configuration is applied on SG2. You need to change the network entity. And then we configure two ISIS processes also, ISIS 20 and ISIS 100. And apply the ISIS on interfaces. So similarly, you need to enable ISIS 100 on aggregation interface and ISIS 20 on the access interface. So SG3, we do the same. We are configuring two ISIS processes also, ISIS 100 and ISIS 30 for the access. So once you've configured the SGs, you also need to configure the CSGs. So for the CSG configuration is almost similar. You need to configure the sysname, configure ISIS process 20 for this is in access ring 1, and then you need to enable ISIS on the interfaces. So we enable on the logical interface loopback 0, and we enable on the physical interfaces. So we do similar configurations for these different CSGs. And we can verify that our sessions are up starting from the RSGs. I will undo terminal monitor. Display ISIS peer. You can see that we have 3 peering sessions, SG4, SG1, and RSG2. So similarly on RSG2, we also have, undo terminal monitor again, display ISIS peer. On RSG2, I'm missing something. RSG2, we have 2 interfaces. I can display ISIS interface. We have 3 of them. Can check on this SG2. Let me go back to RSG2. Display ISIS interface. So we have 0, 1, and 2. Display ISIS peer. We only have 2 peering sessions, which is RSG1 and SG3. So we need to check if I do display IP interface brief, just to ensure that we have an IP address assigned on this one. We have .716. So you can see that we have assigned a wrong IP address on this interface. So as part of troubleshooting, you need to check this in detail and be able to identify where you are facing issues. So I will do IP address 10.10.10.7. 706. Let's check the one that is configured on SG2. IP interface brief. You can see this side it's 7, so we need to make it 6.31. Display ISIS peer. So we have our 3 peering sessions are up. So sometimes you make errors when you are configuring, and you should be able to easily identify the causes. What is causing the SIS not to come up? What is causing the BGP peering session not to come up? So we have 3 peering sessions on this RSG2. On SG2, we also expect to have display ISIS peer. We have 2 peering sessions in aggregation. Remember, it has a connection to RSG2 and SG2. So those are the aggregation processes, and the peer is up. We also have a peering to CSG3. So this one we do display ISIS peer on SG1. We also expect 2 aggregation peering session and 1 access session. Finally, on SG4, I can do display ISIS peer. You can see that we have 2 aggregation peering sessions and 1 access session. On CSG2, I can do ISIS peer just to verify that our peering sessions, we have a peering session to CSG1 and we have a peering session to CSG3. So this one verify that our SIS is running okay. We can do, let's first do the route import. So once you've configured the access and aggregation processes, I've mentioned that we need to perform route import. And route import should be done using route policies. You don't just import everything. You need to configure some IP prefixes to match what you want to import, and then you use route policies to control what needs to be imported between different ISIS processes. That's a best practice, and it can help you to avoid loops. So we are creating IP prefixes because we need to import the loopbacks of aggregation nodes to the access. So we are creating IP prefix import aggregation loopbacks index 10, and then we are merging the loopback 0 of SG1. Once we've done this, we also configure an IP prefix to match the point-to-point and the loopback 0 of the CSGs. So it's greater equal to 30, less equal to 31. So it will be importing routes with masks ranging from 30 to 32. So once we've configured the IP prefix, we are configuring route policy. The first route policy is to import access to aggregation, permit node 10, and then we are merging the IP prefix for access to aggregation. The second policy is to route policy to import aggregation loopbacks. So we are merging the IP prefix of import aggregation loopbacks. And once we have configured the route policy, the next step is now to import the routes. So in ISIS 100, we will be importing ISIS process 20, and we are specifying the route policy of access, import access to aggregation. So once we've done that, we also import routes, ISIS process 20, and we import routes we are importing the direct route. Remember, we need to be able to reach these loopback 0. So we are using import route direct, and cost should be 1,000. We are adding a cost of 1,000 whenever we are importing this route to ISIS 100, to ISIS 20, the access process. And we are using the route policy. Remember, we are importing direct routes, but only the one that matches this route policy, the loopbacks. So similar configurations are applied on SG2 to import the loopback 0 of SG2, and also to import the route that are coming from access and access rings. So similar configuration on SG3, SG4. So if we check on SG1, if I do display IP routing table, you can see that we are learning the loopbacks from all these nodes. We are able to learn from the RSGs, from the CSGs, but the CSGs in access ring 2, we are not able to get the loopbacks in SG because we haven't done that. We are only importing the access 1 to 100 on these SGs. So if I do on the CSGs, I can display IP routing table just to verify that I'm able to get the route. There is a separate session where we demonstrate that you are not able to get the routes when you don't have the route import. You can just check on our series, on the IPRAN training series, and you'll be able to understand better. So you can see that we are getting the loopbacks of 3333 and 4444. This is for SG1 and SG2. So we should be able to reach 3.3.3, and we should also be able to reach 4.4.4.4. And on the SGs, we should be able to reach 7.7.7. Let's check SG2, display current configuration. Display IP routing table. We have 777 on SG2, display IP routing table. We have it here, it's pointing to 10.10.10.8. So we have the routes to the CSGs. So once we have verified that we have proper route import between these processes, we can also do the same for the other ring. If I do display IP routing table, you can see that we are learning the route from the CSGs, and on the CSGs, we should also be getting the routes from the aggregation nodes. We have 555 and 666. So this confirms that our route import is okay, and we are only importing the loopbacks from the two SGs to the access process. So once we've done the route import, we have reachability between the SGs and CSGs. The next step is now to implement BGP. So for BGP peerings, I've mentioned that we have to take a snippet. We have to configure BGP peering sessions from CSGs to SGs. And given that we have 2 SGs per ring, it's always recommended that we do peering session to both SGs. so that we have redundant peering sessions. On the ASGs, we'll also do peering sessions to the RSGs. So this one will establish a peering session to RSG1, and SG2 also will do the same. This one will also establish a peering session to RSG2, and this one will also establish a peering session to RSG1. So similarly, in ring 1, we'll do the same, a peering session to SG1 and a peering session to SG2. And this SG3 will establish a peering session to RSG2 and also a peering session to RSG1. So we have redundant peering. In case we are losing one peer, we are able to get route from the other peer. So we have redundant peering sessions established between the CSGs and ASGs and between ASGs and RSGs, just to ensure that we have redundant peering sessions. So for the BGP configuration, and I also need to mention that we are using groups, so we'll be configuring groups to help us efficiently manage these peering sessions and also to reduce on the workload. So when we are using groups, remember there are so many common configuration or repeated command that we need to run on each peer. So with peering groups, we are able to minimize the number of configuration that we need to run and also to easily manage, efficiently manage the peering sessions. So we are creating groups. On SGs, on the RSG, we are creating a group called RSG to SG. So we create a group RSG to SG and we bind all the SGs into that group. So you can see that we are binding all the SGs to the group RSG to SG. So once you've configured that, of course, you need to, we are not using the unicast, we are using VPN v4 peering sessions. So you also need to enable under these VPN v4 peering sessions. And many times you don't have to run this PR55 to enable. You just run on the group and it will be enabled. The peer will be enabled by default. So you just run this command. So on RSG2, we do the same. And another thing to mention that we are configuring the router ID using the LUBAC0 IP. So we also create a group RSG to SG, and other configuration are the same because we are peering to the same nodes for the RSGs. So after configuring the RSG, now we have to configure the SGs. So on the SGs, remember we are peering to the CSGs and also peering to the RSGs. So on the SGs, we are configuring two groups. We have one for SG to CSG. This one will be the one to add the peering to the CSG sessions. And then we have SG to RSG. So we have another group, SG to RSG, and we are adding our two RSGs, 1.1.1.1 and 2.2.2 for RSG1 and RSG2. We are also specifying that we are connecting using LUBAC0. So once we've done that, we enable them. You need to enable the groups, SG to CSG, and also the group SG to RSG, and map the CSGs and the RSG to the correct groups. So on SG2, we are doing the same. We are creating the two groups, SG to CSG and SG to RSG, and binding the peers to the required groups. Once we've finished configuring the ASGs, we can now move forward and configure the CSGs. So the CSG configuration is simple. We are also creating a group. So we are configuring route ID using the LUBAC0 IP, and we are creating a group CSG to ASG, which is an internal group. Remember, this is for IBGP, so it's internal. Even when you are configuring and you don't specify it to be internal, it will be internal by default. So unless you make it external, that's when it will be an external group. So we are specifying CSG to SG to use loopback 0 as the connect interface, and then we are configuring the peering sessions to the SGs. So you can see that on CSG1, we are configuring peer sessions to SG1 and SG2. As I've highlighted on the topology, we are configuring CSG2 has to peer to SG2 and SG1. Similarly, CSG1 will also do the same, and CSG3. When it comes to CSG4, 5, and 6, they will be peering to SG4 and SG3 so that we have redundant peering sessions. So these are the configuration that we are doing on the CSGs. So on CSG4, you can see we are specifying the route ID, we are creating the group, and then we are peering to SG3 and SG4. So these are the configuration that we need to make for BGP, and we can verify that once we've done those configuration, our BGP peering sessions should be up. So if I run display BGP VPN v4 all peer, this is the command that you use when you want to view the VPN v4 peering sessions. You can see that on SG4 we have 4 peering sessions. We have a peering session to 1.1.1 RSG1. We have a peering session to 2.2.2.2, which is RSG2, and then we have 3 peering sessions to the CSGs that are connected to SG4. You can do peer and then specify verbose, or you can indicate the peer that you want to see details, so it will give you more details. Active hold time, the hold timers, how long it has been up for almost 1 hour, 13 minutes, 13 seconds. Then the router ID, the BGP version that we are running, the type, it's IBGP peering session, the PIP address, it's here, the remote AS, and many other details that you can, the received messages, send messages, authentication configured. We haven't implemented authentication for this lab, but we will be implementing authentication later. The keeper lives, route refresh capability, the 4-byte AS capability has been enabled, connect interface has been configured. Peer preferred value, we haven't configured any preferred value. The routing policy configured, we haven't configured any routing policy. So that is why it's indicating that no routing policy is configured. And we can see the detail for other peering sessions. You can see the port, the local port is random, but the remote port is always 179. Once we've done that, we can also verify on the RSG, display BGP VPN v4, all peer. So on RSG1, we have 4 peering sessions. Remember, we have 4 SGs, so we have 4 peering sessions established towards the SGs. And on the CSGs, we can also verify that we have only 2 peering sessions. So we have 2 peering sessions to the SGs, SG1 and SG2. On CSG2, we also expect to have, we have 2 peering sessions to SG2, to SG1 and SG2. So this is proof that our configurations was okay and our peering sessions are all up. But if you check, remember we haven't advertised any routes. If we check display BGP, VPN v4, all routing table, we haven't done any route advertisement in BGP. So these are things that we'll be covering in the upcoming videos. And in our next step, we'll be seeing how to implement MPLS on the IPRAN network. Remember, at the end of the day, we need to have services running, the VPN services running on our network. So in our next episode, we'll be discussing, in our upcoming episodes, we'll be discussing how to deploy services, how to deploy MPLS, and then we can see how route advertisement is done on IPRAN network. Thank you for watching, and please, you can reach out if you have any questions. You can leave your comments in our comment section. And if you need the lab setup, you can also request either via LinkedIn, or you can leave a comment and I'll be able to share the configurations to you. Thank you for watching, and stay tuned for more upcoming videos on our channel. Thank you.